NPL is the UK's National Measurement Institute and is responsible for developing and maintaining the nation's primary measurement standards. It aims to be an exemplary national laboratory, undertaking excellent science and engineering to deliver extraordinary impact for the UK. Our research brings together scientists and engineers from every field to underpin the UK's prosperity and quality of life. As a national laboratory, our advice is always impartial and independent, meaning consumers, investors, policymakers and entrepreneurs can always rely on the work that we do. The magnetics team at NPL has carried out magnetic material and sensor characterization for over 50 years and is the only UKAS accredited magnetics laboratory in the UK. We provide measurement services that support both UK and internationally based companies in all sectors and of all sizes, as well as universities and other national metrology institutes. The measurement capability and research activities of the magnetics team at NPL can be categorized in three main areas: material characterization of the magnetic properties of soft and permanent magnetic materials, with developments ongoing to increase the range of conditions that these measurements take place in; characterization and calibration of magnetic sensors from a nanotesla range to several Tesla over a range of operational conditions; and development of these material and sensor measurements to provide non-destructive testing solutions to real-world measurement challenges such as defect detection and characterization. Soft magnetic materials measurements cover both structural and electrical steels, and measurement services at NPL include both DC magnetic properties that can be measured from the initial magnetization curve and hysteresis loops, as well as AC magnetic properties such as power loss using systems such as Epstein frame, single sheet tester and ring measurements. Currently, these measurements are for frequencies up to 2 kHz, but there is ongoing work to increase the range of frequencies that can be tested, as well as testing at operational temperatures. As well as measurement of soft magnetic materials, we also measure the magnetic properties of permanent magnets. From the demagnetization curve, we can measure properties such as remanence, coercivity, and maximum energy product, and using open circuit techniques can test real-world sample geometries at a range of temperatures, with traceability provided by calibration against closed magnetic circuit measurements. Lab-based measurements of standard geometries and at standard conditions are not always characteristic of the material in operation, nor of its lifetime properties. So for this reason, work is ongoing to extend the range of conditions that measurements can be made under. In addition to this, materials can be aged using thermal cycling at temperatures from -60 to +160 degrees Celsius, representative of an automotive environment. Also, measurements can be made to assess the impact that stresses, either from a manufacturing process or during operation, have on material magnetic properties. One example of an ongoing research project that NPL is involved in this area is the Edison project funded by Innovate UK. In collaboration with companies and universities across the UK, this project aims to develop a novel permanent magnet motor technology, as well as developing corresponding electromechanical analysis tools. Material testing at NPL of the various motor components will feed into the analysis of the motor, as well as enabling development of software. Another project which has recently started is a European project called HEFMAG, which aims to examine standard energy tests at extended frequencies and power levels and devise new measurements for power loss at high temperatures, as well as examining the effects of mechanical damage on efficiency measurements. The construction of higher efficiency machinery will reduce energy losses and allow existing regulations and future efficiency targets to be met. Thank you for listening to this overview of magnetics at NPL. If you'd like to find out more, please feel free to send a message using the chat function or visit our website at npl.co.uk/electronic magnetic materials.